All right, welcome to Path Geometry. We're looking at one of our first notes on factoring. And the focus of this is factoring out the greatest common factor. Factoring out the GCF, or greatest common factor. And so this is actually the very first step in any factoring problem that we'll be doing in here, whether we're factoring a trinomial, or just a binomial, or maybe even a four-term polynomial. We need to be able to factor out the greatest common factor. So we're going to look at just a couple quick examples of this that you should write down. And the first one, we do want to put the terms in order if they're not already in order. Our first one is going to be 12x plus 80x squared. And so with this, we look and say, okay, well, they're not in order because the highest exponent should come first, then the next lowest exponent, and then if there's just a number, then the constant, which is the number at the end. We don't have one of those in this case. So this should have been the first term, 80x squared plus 12x. Now the problem's in the terms are in the correct order. When I look at this, I'm looking for the greatest common factor. So between the 80 and the 12, the largest number that will go into both of those, 12 won't go into 80, but I believe is 4, because I believe 80 is 4 times 20, and 12 is 4 times 3, and 3 and 20 don't have any common factors. So the greatest common factor number-wise is 4, and then variable-wise, I look and say, okay, I have 2 factors of x here, and 1 factor of x here. I could divide 1 factor of x away, or take 1 factor from both of these 2 terms. So my greatest common factor is 4x. And what I'm doing is doing the reverse of distributing, the reverse of multiplying. I'm factoring out what was multiplied. So I often think about, okay, what times 4x would be 80x squared? But a lot of people like to actually go through and divide it, which is fine. So 80 divided by 4 is 20, x squared divided by x is x. 12x divided by 4x is just going to be 3. For me, I say 4x times what is 12x? 4x times 3 is 12x. 4x times 20x is 80x squared. So these are the factors of this expression when we pulled out the greatest common factor. We're going to look at just a couple more of these. Take a look at example 2. Example 2, we're going to have negative 24x minus 48y. Now, they are in alphabetical order, so that's good. And we don't have any exponents that are out of order that we need to put in order. We do have a negative first term, though. So when I do that greatest common factor, I'm going to pull out a negative so that my first term can be positive. It makes the rest of the problems that we'll do later much easier. So I'm going to pull out a negative, and between 24 and 48, I know 12 goes in, but 24 actually goes into 28. So with 24, it'll be 24 and 1. With 48, it'll be 24 and 2. So I'm going to factor out a negative 24. In terms of the variable, I can't factor an x away from both because there's only an x here. I can't factor a y away from both because there's only a y here. So I can only factor out the negative 24. When I go through and divide these both by negative 24, I am left with positive 1x and positive 2y. If I were to distribute this back in, I would get negative 24x minus 48y, which is the whole goal. All right, let's look next at example 3, which will be we're actually going to do 45r squared minus 60r cubed. With this problem, they're not in the correct order. So I am going to rearrange them. That's going to make this negative 60r cubed plus 45r squared. Now I notice again, now my first term is once again negative. So when I do my greatest common factor, I am going to pull a negative in front. I'm also going to look at the numbers 60 and 45. They won't go into each other, but 15 will go into both of them. 15 times 4 is 60, and 15 times 3 is 45. And so I'm going to pull out a negative 15. Then I look at the variables. I only have r cubed and r squared. So the most I could take away, I could take 2 factors away from here and 2 factors away from here. I could pull 3 away from here, but I couldn't pull 3 from here. So it's usually my lowest exponent. In this case, both terms have at least r squared, so I can divide away or factor out an r squared. So this is going to give me negative 15 r squared as my greatest common factor. When I divide each of these by negative 15 r squared, a lot of people like to write that to start. This leaves me with positive 4r. And this leaves me with negative 3. If I were to redistribute this, this would give me negative 60r cubed and positive 45r squared, which is what we started with in terms of the values of the expression. So I know I've factored correctly. We will see some binomials that can factor further. If you look, these are linear factors that are left. We'll talk more about that later. Right now, we have one last example. We're going to look at example 4, and this is where we start with actually a trinomial with more than one variable. So we're going to have 30m squared p plus 12m squared. Oh, no, I'm sorry. This should have been, I stand corrected. Let me do this. 30m squared p plus 12m p squared minus 18m. So there's my three terms. In terms of the number, I'm looking at the 30, the 12, and the 18 for my greatest common factor. I've got 30, 12, and 18. I know a number right now that will go into all of those. 12 won't go into them. 18 well, obviously wouldn't, but I do believe 6 by 2, 6 by 3, and 6 by 5. 6 is my greatest common factor of those three terms. So I will have that as part of my GCF. And then in terms of the variables, I have an m squared here and one factor of m here and one factor of m here. Since all three terms have at least one factor of m, I'll be able to divide out that factor of m. I have a factor of p here, two factors of p here, and 0 factors of p here. Since there are no factors of p on the third term, we will not be able to factor out any of the variable p. So when we divide each of these expressions by 6m, the 6m is our greatest common factor of these three terms. Here I'm left with 5mp. Here I'm left with 2, the m's cancel, so 2p squared. And here I'm left with negative 18 over 6, the m's cancel. I'm left with negative 3. If I were to distribute the 6m back in, I would get 30m squared p, 12mp squared, and negative 18m, which is what we started with. So I know that I have taken out the greatest common factor, as long as it was the greatest common factor, and no other factors will go evenly into these three, then I've done the greatest common factor. The next clip that you'll see will be about factor by grouping. That is where we actually have 4 terms in the polynomial. So instead of a trinomial or a binomial to start, we'll actually start with 4 terms.